Welcome to lessons 8-11, 12, and 13. So 8.11, 12, and 13. And this is the final lesson in this particular course. All right, so what I'm going to do is I'm going to swap between several different screens because we're going to be drawing Lewis structures. But first off, these are the notes that you have access to that you can print off and kind of work through. I'm not going to work through every problem on the notes in this video, but I will show you the completed handout in this video so that you can work through them and do them yourselves. So anyway, first off, before we start Lewis structures, some things you need to know. You only include valence electrons when you're doing a Lewis structure. There are a couple different things in terms of how many electrons particular elements want to have. Hydrogen follows what we call a duet rule, where it's most stable when it shares 2 electrons or has 2 electrons. And then your second row nonmetals and they obey something called the octet rule. Now, there are exceptions to the octet rule. The octet rule means it's most stable when it's surrounded by 8 electrons, whether they're bonded or non-bonding electrons. But we'll get to those exceptions later as we go through. So steps for writing Lewis structures. You are going to sum the valence electrons. You're going to use pairs of electrons to form bonds between each pair of bound atoms, and then you're going to arrange the remaining electrons to satisfy the duet rule for hydrogen and the octet rule for the second row elements. So let's look first at practice problem number 1 here, and I'm going to shift over to the PDF document. So notice Lewis structure for water is here. Or sorry, the formula for water is there. Now what I've done here is I've summed the valence electrons. So hydrogen has 1, another 1 for the second hydrogen, and then oxygen has 6. So what you'll want to do is you want to note that there are 8 electrons. Now, what you try to do generally when you're drawing Lewis structures is to make the molecules symmetrical. So in this case, you'd put the oxygen in the middle and the hydrogens on the end. But please note that hydrogens are always terminal atoms. They cannot be bound to 2 different things because they satisfy the duet rule. So let's go ahead and use paint here. We have 8 electrons that we're dealing with. Let's see, get back to the pencil. We have 8 electrons that we're dealing with. We put oxygen in the middle, and then we need to bind the other atoms to it. Once we've done that, we make sure everything satisfies its rule. So hydrogen has 2 electrons around it because that bond between the H and the O is 2 electrons. So each of the hydrogens is okay. The oxygen only has 4 electrons around it right now because each of the bonds signifies 2 electrons each. So we need to draw 2 lone pair on that oxygen atom. And so now everything is satisfied in terms of the duet rule, the octet rule. Now we need to make sure that we've used only the number of electrons that we were allowed. We're allowed 8 electrons. So 2, 4, 6, 8. That's a total of 8 electrons. So that's the correct Lewis structure. Now what we're going to jump into is something called Vesper theory. And Vesper theory, the easiest way to do this is to figure out what the AXE designation is. So what we'll do is we're going to look at the central atom here. A just represents that central atom. X is how many things are attached to it. So there are 2 things attached to that central atom. So you put a 2 there. The E is how many electron pairs, lone electron pairs are on it. And that's 2. So that would have an AX2E2 designation. And so if I go to this cheat sheet for the Vesper theories, what I'm going to do is I'm going to look down here at type, and I'm going to see I'm going to look here at type, and I'm going to see what AX2E2 means. So nothing on the top because all of those are E0s at the end. There's an AX3E0, AX2E1. Here's an AX2E2. So what that means about shape is it means that its electron pair geometry is tetrahedral. Its molecular shape is angular. So you'll see more about this as we move along. So let's go ahead and let's look at the next one. Gives you lots and lots and lots of different examples. What we're going to do is we're going to look at this one here. So we're going to look at NO+. And so we'll go back to paint. Let's see. And we're going to go NO, was it 3+? Let's back at that. No, it's NO+. Okay, so let's go back to paint and let's get rid of that 3. So it's NO+. All right, so first thing we're going to do is we're going to figure out how many valence electrons, and you figure out valence electrons by looking at the periodic table. And so really what you're going to do is you're going to ignore the transition metals, those metals in the middle, and then you're going to kind of count across. So if you have a periodic table that has a 1A, 2A designation, then it's the number in front of the A that tells you valence electrons. If you have the newer periodic table that just numbers the rows 1 through 18, it still kind of works because 1 and 2 have 1 valence electrons and 2 valence electrons. And then you move clear over to 13, which is the column that has boron at the top. That would have 3 valence electrons. So what we'll do is we'll just cut off the tens place and put a 3 there. So when we do that, we notice that nitrogen is in group 15, and so it has 5 valence electrons. Oxygen is in group 16, so it has 6 valence electrons, and that plus sign means I lost an electron. So I have a total of 10 electrons to work with. And so if I go ahead and draw nitrogen and oxygen out and go ahead and add electrons, so each satisfies the octet rule, then when I go back and count, well, first off, anytime an ion has a charge on it, we need to make sure we put square brackets with that charge on the outside. But anyway, let's go back and count 2, 4, 6, 8, 10, 12, 14 electrons. That's too many. We don't have that many to work with. So what we're going to do is we're going to make a double bond here. Okay, a double bond, and then I have to get rid of electron pairs to make sure everything still satisfies the octet. So now I have 2, 4, 6, 8, 10, 12. So again, I'm going to have to get rid of some electrons and make it a triple bond. So 2, 4, 6, 8, 10. So now each atom has 8 electrons around it, and it satisfies the number of electrons I'm allowed to have. Okay, so that's what you do if there's a charge. Now, if there's a negative charge, you'll need to add instead of subtract. So you can kind of see my work as you go through this document. Some different things going on. Notice here it says boron tends to form an atom that has fewer than 8 electrons. So it's okay with 6, beryllium's okay with 4. And so just kind of follow down through there. There's when I start giving you more of the AXE designation. Molecular geometry, electron pair geometry. And so those are just some different practice molecules that you can work with. If you have questions on those, please visit with your instructor, and please practice with those and find any work you can or any extra practice you can on different sites like Quizlet or Khan Academy or so on. Well, that concludes this lesson. Thanks for joining.